work on annotating our STAAR reference materials. So to get started, we are going to start by writing a line times 10 to the power of a number. And so remember, this is for scientific notation. And this number right here, this first number is called the coefficient, and it has to be a number between 1 and 10. And so if on your test there's any answer choices that have a number greater than 10 or less than 1, we know that that's not the correct answer. We have to remind ourselves that with this exponent, if the exponent is less than 1, the number is super, super small, so it would be something like 0.0000 other numbers. And if the number is greater than 1, this ensuing number would be really big, like billion, million, trillion. Then for slope-intercept form, when we type it into decimals, we don't type it in as y equals mx plus b. We are going to type it in as y1 tilde mx1 plus b. And then for direct variation, it gives us the equation y equals kx. So remember, for slope-intercept form, that is for non-proportional relationships. Direct variation is for proportional relationships. And we know that k, to find it, that's going to be equal to y over x. Slope of a line, yes, is y2 minus y1 over x2 minus x1. And we know that b over here represents the y-intercept. But I'm going to also write 3 keywords that usually appear in word problems for slope, which is per, each, and every. Okay, so for circles, under circumference, we know that the circumference is the distance around a circle. So it's similar to a perimeter, but because it's a circle, it has a special name. We have c is equal to 2 pi r, or c is equal to pi d. Because we know that to get the d, we would multiply 2 times r, that explains why the equations are equivalent. And then, of course, to find our radius, if we're given a diameter, we would have to do the opposite. So here we're multiplying our radius times 2 to find the diameter. To find the radius, if we know the diameter, we would be dividing by 2. Okay, so we don't really do much annotations for area. These are the formulas that are given to us. Little b stands for base length, h stands for height. And then, of course, for circle, we have the area of a circle, which is area is equal to pi radius square. So for here, for surface area, what we annotate, I'm going to go ahead and type it instead of writing it because it takes me longer, is when we type it into des, we change this equal to sign to a tilde. So it becomes s tilde and then ph. And this p stands for perimeter. So I'm going to go ahead and also write that. Okay, so again, the rest of these equations, we really just change the equal to sign to a tilde. So s tilde ph plus 2b. Over here, I'm going to write it just because it's hard for me to type the pi. So we have s tilde 2 pi r h. And then for the last one, it's going to be s tilde 2 pi r h plus 2 pi r squared. Okay, so for volume of a prism and cylinder, we use the V equals BH formula, but we know that a cylinder is special because its base shape is a circle. So we know that an alternative formula is V tilde. The area of a circle we can find up here, which is pi radius square. So we have pi radius square, and that's the same thing as B. Again, B stands for base area, or area of the base. Okay, so for a pyramid or a cone, we use the formula V is equal to 1/3 B times H. And depending on what type of pyramid it is, you might have a rectangular pyramid or a triangular pyramid. Your B would be whatever the shape of the base is. But in 8th grade math, we mostly use it for the formula for the cone, which is V tilde, and we're keeping the 1/3. But again, with a cone, we know that the shape of the base is a circle, because this is what a cone looks like approximately. And so because the area of a circle is found by multiplying pi radius square, we're going to do that again. And lastly, we have the height. And then for a sphere, it's the same formula we have here since it already has the radius in the equation. But again, we're changing the equal to sign to a tilde. Okay, so now on to the additional information. For Pythagorean theorem, a squared plus b squared equals c squared. That's used to find the distance and the lengths of the different sides of a triangle. So it's important to draw a triangle, but you still need to know what letter goes around each side. So I usually have my height of the triangle as my A, and then my base of the triangle as my B. And then we have a right angle right here. And I need to always remember that opposite of the right angle is my longest side, and that is my hypotenuse. So this C is called my hypotenuse. It's along the side and it's opposite of the right angle. And A and B are called the legs. And so that's my annotation for Pythagorean theorem. For simple interest, we have I equals PRT. So anytime we have the equal to, I usually am going to have to rewrite that as tilde. So we have I tilde PRT. But also there's sometimes simple interest problems that will ask you to find out the total amount. So we know that our A is used to represent the total amount. So to do that, to find the total amount, I'm going to add the principal, which is the original amount, plus the interest. Then over here again, we have, for compound interest, we have A equals P parenthesis 1 plus R to the power of T. And so to type it into Desmos, if we're trying to find our total amount or even our interest, I'm going to change the formula to have a tilde sign instead of that equal to sign. I'm just going to write the T. Okay, then there's sometimes compound interest problems that are going to ask us to find the interest. So this is the opposite of finding the amount, right? So instead of adding, we're going to do the opposite, which is subtracting. So we're actually going to subtract the total amount minus the principal. And I should have done this earlier in retrospect, but I'm going to list out T pair, which is what each of the letters mean. So it's letter T, letter P, letter A, I, and R. Okay, so T stands for time. I'm going to just type this because it's going to take less time. Okay, so T stands for time, and it has to be in years. If it's in months, we're going to convert it by dividing. So we know that there's 12 months in a year. So if the word problem gives us the number of months, all we have to do is divide whatever number that is in months and divide it by 12. Okay. P is our principal or our old amount, our original amount. A is our new amount or our new number. I is our interest and R is our interest rate. So that's usually expressed as a percent. And there's multiple ways to turn the rate into a decimal because we do need to calculate it as a decimal. So one way is to divide. So whatever the percent is, dividing it by 100 because percents are always out of 100. Or on Desmos, once you type in the percent sign, it's going to always have percent of, and you need to type in the number 1. So it's always percent of 1. Okay, so this is the front side of our STAAR reference material. On the back, you need to go ahead and make 4 big boxes or separate it. And our 4 types of transformations include reflections, dilations, translations, and rotations. So I like to start off with reflections because it's one of the easier ones to remember. So a shape can be reflected across the x-axis or the y-axis. And the one thing to remember when it's reflected across the x-axis is that the x-coordinate stays the same. Because we know that all rules, at least for transformations, start out with x comma y. So that's the original point or the old point. And so as you can see, when it's reflected across the x-axis, the x-coordinate stays the same. It's the y-coordinate that changes signs. So it's the opposite sign. So here it says negative y. But if our original y-coordinate was already negative, like negative 3, it would just become positive 3. Okay, so when a shape or a point is reflected across the y-axis, it's the y-coordinate that stays the same, and our x-coordinate is the one that changes sign, so it becomes negative. Next is our dilation. So again, dilation always starts off with x comma y, arrow, and this time we're using kx comma ky. With dilation, we're always multiplying. Dilation means that we're multiplying. The shape is either getting bigger or smaller, and k, this is usually a number, is called the scale factor. So if the number is bigger than 1, our shape gets bigger. If the number is smaller than 1, whether it's as a decimal or whether it's as a fraction, so some examples of this could be 0.5x comma 0.5y. Sometimes our answer choices or our scale factor or rule will be given like that. And other times they'll be given as a fraction, like 1/2 x comma 1/2 y. Okay, next we have translation. So again, all of our rules start with this x comma y arrow. But over here for translation, the important part of our rule is the x plus or minus a number, comma y plus or minus a number. So we are going to draw a line here. Go ahead and draw this line and with the arrows and label it left and right. So if you're going left and right, that's going to be affecting the x coordinate. And we know that if you're going to the left, you're going to be subtracting. So I wrote plus or minus because it could be either order. For example, if we were going 5 units to the left, the rule would be x minus 5. And then if we're going to the right, we're going to be adding. So let's say we're going 10 units to the right, you'd be adding. Okay, then you're going to draw a vertical line and you're going to label it up, down. And this represents the y-axis for the y-coordinate. So if you're going up, that means you're going to be adding. And if you're going down, that means you're going to be subtracting. So for example, if you're going down 3 units, our rule would look like the second part of our rule, because each of our rules need an x and a y, would look like y minus 3. And if we were going 7 units up, our rule would be y plus 7. Then finally is rotation, where the two directions that we can rotate a shape or a point is clockwise like this or counterclockwise like this. And the different degrees that a shape can be rotated is 360, 90, 180, and 270. So if we had a shape that started in this quadrant 1 right here, and it was rotating clockwise, every quadrant is a 90-degree rotation. So if it started here and it rotated here, this was the 90 degrees clockwise rotation. And then we have, if it started here and went here, this is the 180-degree clockwise rotation. And finally, if we have it starting here and going into quadrant, it would be a 270-degree rotation. And if it went all the way around back to the same place, that'd be 360 degrees, which is, we know that all the rules start with x comma y, but if it did a 360 rotation, it would land back in the same place, which is why it's x comma y. And then for a 90-degree rotation, it's special. So you actually have to flip the x and the y coordinate. So the y coordinate's first, x coordinate second. For 180, you keep x comma y in the same location. For 270, again, you're flipping so that the y coordinate comes first, the x coordinate comes second. And the way that I like to remind my students on how you know which letter is flipped signs is we start with 90 degrees. We don't touch the 360. And I say a soldier goes right, left, right, left. So that's where you draw the negative signs in front of. Then we have to remember that counterclockwise is the opposite. So for counterclockwise of 360, that's the same thing as, clockwise of 360. For counterclockwise of 180, it's the same thing as clockwise of 180. But for counterclockwise of 270, so let's say I went 270 degrees. So starting here, instead of going clockwise, I'm going counterclockwise. So this would be 90, this would be 180, this is 270. That is the same thing as going clockwise of 90 degrees, which is why these two rules are the same. And then again, counterclockwise of 90 degrees is the same thing as clockwise of 270 degrees for the same reason. And that's all of the annotation notes that you need to know for the STAAR reference material. Now it's your time to practice.